Alright, let's continue on to page 462. We're going to do two examples from 462 and then you should be good to do your homework. So we're going to start with number 18. Number 8. We're going to refer to the sample data from exercise 7. We're going to use a 0.05 significance level to test the claim that the treatment group and the placebo group come from populations with the same mean. So the mean of 1 is equal to the mean of 2. Alright, and the statistics that are given for the placebo, N is 43, X bar 21.57, S is 3.87, and for the treatment group, N is 33, X bar 20.38, S is 3.91. Alright, so this is our original claim. The opposite of that would be mu1 does not equal mu2. So our null hypothesis, alternative hypothesis. So we're going to use 2 SAMP T test to test the claim. Stat test 2 SAMP T test is 4, and we enter all the statistics. X1 is 21.57, S1 3.87, N1 43, X2 20.38, S2 3.91, and N2 is 33. So our alternative hypothesis is mu1 does not equal mu2. Mu1 does not equal mu2, so we should highlight not equal to. Do not pull them, and calculate. Test statistic and p-value 1.32. And the p-value is 0.191. 0.191. Alright, we're going to compare this to the significance level, 0.05, and it is not less than the significance level, so we're going to fail to reject the null hypothesis. So there is not, since we're failing to reject, sufficient evidence to our original claim is the null hypothesis, so we're going to write reject the claim that, restate our original claim, mu1 equals mu2. Critical value, it's a t distribution, so we're going to use t interval. So we go to t interval in our calculator, stat test t interval, and we're gonna, for the sample mean we should have 0. For the sample standard deviation, the square root of the smaller sample. The smaller sample is 33, square root of 33. N is 33. And the confidence level we're using, since the critical value is in both tails, we're going to use 1 minus alpha. Alpha is 0.05, so 1 minus 0.05 is 0.95. Hit calculate. We're going to have positive and negative 2.04. 2.04. Alright, we're all done with problem number 8. Last problem we're going to do is problem number 10, same page. Alright, number 10, we want to construct a 90% confidence interval estimate for the difference between the two mean reduction in pain. Alright, so we have magnet and we have sham. And let's see, the statistics that are given for both. For the magnet, N is 20, X bar is 0.49, S is 0.96. For the sham, N is 20, X bar is 0.44, and S is 1.4. So we're going to use 2 samp t interval to construct the confidence interval. Stat test 2 samp t interval. We need to scroll down till we get to it. 2 samp t interval. Alright, x1, x bar 1 is 0.49, s1 0.96, n1 is 20, x bar 2 is 0.44, s2 1.4, n2 is 20. Confidence level we're using is 0.9. Should not be pulled. And calculate. So we have negative. We should round our interval to the same place as our statistics, so the hundredths place. Negative 0.59. To 0.69. We're 90% confident that the interval from negative 0.59 to 0.69 can change the true difference between the population means. Alright, all done with section A3.